Hey guys, welcome to the test 5.1 reteach. So we're going to be going over questions from test 5.1, and then after you finish this you'll get another attempt so that you can do the reassessment. Okay guys, if we look at question 1, you're going to see a factoring question, and this is going to match up with our a cubed minus b cubed formula. So if we can identify what a cubed and b cubed are, we're going to be able to very easily figure out how to fill this in. So our formula again is going to read a minus b, a squared plus ab plus b squared. Okay, and you can find all of these factoring formulas on page 69. All right, so let's start by identifying what a and b are going to be in this problem. Well, 216 is 6 cubed, and I've got x, so 6x cubed, and minus 125 is going to be minus 5 cubed. So once we've got those, we can kind of fill in the blanks in our problem here in the formula. We'll have 6x minus 5. 6x squared gives me 36x squared. 6x times 5 is going to give me plus 30x. And 5 squared is going to be 25. So in this problem, we identified a as being 6x, b as being being 5. And we plugged them into our formula. And each of these you can kind of match up the pieces and see. So we're looking for, hey, which one of these is actually a factor from my answer choices? So 36x squared plus 30x plus 25 looks like this very first one. All right. Okay, if we look at question 2, it says, hey, can we select all the factors? So again, we're going to need to factor before we can do anything else. So this is actually a quadratic form question, so it looks like a quadratic, even though it's a higher degree polynomial. Here we go. First, we're going to start out by saying that u is actually just x squared, and we're going to reduce these powers down to something a little more friendly. 3u squared minus 13u plus 4. So basically, I just turned all of these down by a certain degree. Remember that x to the 4th is x squared. So when I changed out my x squareds, I made that a u. Now let's factor this. Take our first number and last number and multiply them. So 3 times 4 is going to be 12. And I want those numbers to add up to that negative 13. So I find negative 12 and negative 1. So we'll split up the middle. Negative 12u minus 1u plus the 4 at the end, 3u squared. And now we can group these. So using grouping, grab the first two, grab the last two. And my GCF for the first two is taking out 3u, and I've got u minus 4. And from the second one, to get it to match up, I'm going to go ahead and pull out that negative 1. So I've got u minus 4. Notice my two parentheses match. They have to match for this to work. Okay, if they don't match, we kind of have to backtrack because we've messed up somewhere. So 3u minus 1 and u minus 4 are the factors that we have right now. Now, don't forget, we didn't start with u. We actually started with everything in terms of x. So this piece right here is going to come back into our problem now. And we're going to have 3x squared minus 1 and x squared minus 4. And I'm hoping this kind of jumps out at you immediately, that x squared minus 4 is actually one of the factoring patterns. It is a squared minus b squared. So that one will break down into x minus 2 and x plus 2. And the other one, however, is not squares, so we're just going to leave it 3x squared minus 1. So the three factors you should find, 3x squared minus 1, x minus 2, and x plus 2. So those would be your three answer choices that you should find. All right, question 3 is asking us about this graph, and it's saying, what's the smallest possible degree we can have? And the easiest way to figure this out is let's count up our zeros and make sure that it kind of matches up with the end behavior as well. Okay, so I know that my end behavior is both sides are going up, and this at least leads me to think that this is going to be a even degree. So overall, I know my degree needs to be even at the end. All right, let's look at this first one. I see at -4, I've got a root, and this looks like it's a single root, so I'm just going to say it has a multiplicity of 1 because it is going straight. Okay. Second one here at -2, that one also seems to be straight, so we've got another multiplicity of 1. And then my last 0 over here at 3, this one seems to be bouncing, and that one has a multiplicity of 2. So remember, based on the shapes we see here, the 3 zeros, 2 straights, and a bounce, which means we add the 3 multiplicities together. So 1 plus 1 plus 2, and we should get 4. So my degree should be 4, and you can see that is an even degree, so this makes sense. So the smallest possible degree is 4. Now, in this problem, they've given us this equation broken down, and so I can see that the roots for my problem are going to be 0, 0, based on this piece. We've got a comma 0 based on the second parentheses, and -b comma 0 for the third piece. Okay, and so if we were trying to figure out, hey, the multiplicity for x minus a, that's my positive 0 based on what we just said. That's got to be this point right here as being a. And based on the shape, this is straight through my graph, which means this has to have a multiplicity of 1. Okay, and b, on the other hand, right here, which is again my -1, so this is b, and that one seems to be bouncing, and anything that bounces, that has to have a multiplicity of 2, so that's my lowest possible one. Remember, this is anything that's even makes a bounce, and the lowest possible one is going to be 2, but it could have been 4, 6, or 8, but in this case the option you'd want to select is 2. Straight through, in order for your graph to go straight through, you can only have the multiplicity of 1 for that shape. Okay. Okay, another graph question coming up here is question 5, and this one asks us to figure out if the leading coefficient is positive or negative, and if the degree is even or odd. So if we kind of look at the end behaviors of the graph, we can try to put it together. So first thing, 2 kinds of degrees. There's an even degree and there's an odd degree. So even functions normally go both up, and odd functions go down first and then up. And then on the other hand, we also have a sign, whether they are positive or if they are negative in front, the leading coefficient. So when you make something negative, that actually just causes both of my arrows to flip over. So evens both go down and odds go up first and then down. And now if we try to just match this up with our graph, so let's look at these end behaviors. This side seems to be going down, my other side is going up. So down and then up, which of my pairs is that? It looks like this one, which means that this is a positive and odd degree. So we've got a positive function coefficient and a odd degree. Okay. Question 6, we got another factoring question coming up here. So this is going to follow the a squared minus b squared factoring pattern. Again, you can find these on page 69, a minus b. Okay, so we're going to look for which one of these kind of factors is listed below. So we got to figure out what a and b are in order to fill this in. So I'm going to rewrite these as squares. So 9x squared, let's make that into a 3x all squared, and 16, well, that's just 4 squared with a y. Okay, so if these are my a and b's, we just fill in our formula and we can find our answer. So here we go, a plus b, so 3x plus 4, and 3x minus 4. And so you can see, hey, look, here's 3x minus 4. And I don't see the 3x plus 4, so that's the only one that matches. So that's the only one we can check off here. Okay, let's factor this one out. So here we go. We've got 10x squared minus 11x plus 3. So the leading number in the front, that 10, is going to be the one that makes this a little bit tricky. We're going to use grouping, and to start that off, we're going to multiply that 10 and the 3 together. So 10 times 3 is 30. Okay, and I need numbers that will multiply to 30 and add up to negative 11. And nothing too bad here. We're just going to get negative 5 and negative 6. They're both negative, okay? That's how you get them to add up to that negative value, even though the last number is positive. So here we go. The middle term is going to split up. So my middle piece is going to split into 2 when I start writing this next step. And here we go. 10x squared. Here's that minus 5x. And then minus 6x plus 3. And we're going to group. Again, grouping means grab the first 2 parentheses and grab the last 2 in parentheses. Once we've got them, let's GCF. So from the first one, I can take out 5x, and we've got 2x minus 1. From the second parentheses, we'll take out negative 3. Okay, again, take out the negative so that we can make this first piece positive. And when I do, I'm going to have 2x minus 1 in here as well. Finally, we can put it together to get our factors. So here we go, 5x and minus 3. Those will become a single factor, and the 2 parentheses of 2x minus 1 are their factor as well. Okay, so these are the 2 factors. You would check both of those boxes if you saw them. Okay, now we're going to be filling in an end behavior in this question. This is question 8, and very simply, we just have to remember our notation, right? So as x approaches infinity, that means along the x-axis, I'm going towards infinity, and this would mean the right-hand side, okay? What is f of x doing? Which way is my graph going? Well, if we look at it, there's my arrow, it's going upwards. So f of x, the y values, are also going towards infinity. So you should have selected infinity in this case. Okay. Given that the polynomial ax squared plus 12x minus 13 goes through this point, 1, negative 4, find the value of a. Okay, and basically we're just trying to figure out what the constant value of a is, and it's pretty straightforward. We have an x and a y value. We just plug them in, and we're going to solve for what that a value is. So here we go. Negative 4 equals a 1 squared plus 12 times 1 minus 13. And as I start simplifying this, a plus 12 minus 13 is just a minus 1, and all of that is equal to negative 4. So negative 4 is a minus 1. We can move that 1 to the other side. And we should get that a equals negative 3 as our answer. Okay, so this is a classifying polynomials question, and you can find all the vocab on here is on page 85. Okay, so if you're not sure what to call something, that's the page to look at. All right, so we're going to start with this problem by combining all of our like terms together. So I see that these are out of order and I don't have like terms yet. So let's start putting things together. Got this negative 3x squared, and I've got 9x minus x and plus 2x. Let's combine them together. 9 minus x is 8x, plus 2x is going to be plus 10x. So when I simplify it, this is what I should have. Now, we want to give this a name based on the degree, which is going to be 2, and there are 2 terms. So if we look at our table, we will discover that this is a quadratic binomial. Okay, now you should only check 2 boxes. Your polynomial has a first name and a last name. There's a degree and a number of terms. Okay, it is not a quadratic linear binomial. No, it is only a quadratic binomial. It only has 2 words associated with it. All right, question 11. Let's factor again. And this one is a cubic, but lucky for us, it's already in 4 pieces. So we can jump straight into grouping. So if we start grouping this, grab the first 2 pieces, what can we factor out from there? Okay, and so from here we can take out our GCFs. So I'm going to try and factor out, in this case, 7x squared, and I'm going to be left with 2x plus 1 in the parentheses. And from the second one, I'm going to take out -5. And the reason we take out -5 is just so that our signs for these first pieces, right here and right here, are going to match up perfectly. So we're going to have 2x plus 1 in there as well. And look, these parentheses have to match. If your parentheses aren't matching, that's definitely an issue. So now that we've got those matching, let's see what we've got as factors. 7x squared minus 5 and 2x plus 1. And there you go. We've got our factored form. Select the factors for those. Neither of those break down any further. Had the first term, the quadratic piece, been something like a difference of squares, we may have wanted to break that down further. But in this case, we're just going to stop there. Okay, this is another identifying and classifying problem. And again, we need to start by putting everything in order and getting the like terms combined. So I'm going to start with 9x to the 5th minus 3x squared. And then I see these two 2x's. So plus 2x and minus 2x are actually going to cancel each other out. And so I'm just going to be left with plus 4. So again, let's look on page 85 and we can check out our vocabulary. So I have a degree of 5. And there are 1, 2, 3 terms, which means together we're going to call this a quintic trinomial. Okay, so remember a polynomial only has 2 names, right? One for the degree and one for the number of terms. It's never counting up. It never has more names the larger it gets. Okay, so this is a quintic trinomial after you cancel out that term. Okay, so that is the reteach portion of test 5.1. This should give you access to a reassessment after you submit it to your teacher. Okay, best of luck and happy studying.